For decades, scientists believed intelligence required a brain. Then, a machine with no neurons, no emotions, and no life experience started solving problems in ways no one expected. It has never seen the sky, never felt fear, never remembered yesterday. And yet, ask it a difficult question and it can reason through the answer. Ask it to plan, and it plans. Ask it to explain its own logic, and sometimes it can. So what is actually happening inside these systems? Are they simply predicting words or developing something that resembles cognition? Large language models weren't designed to think. Their original task was surprisingly simple: predict the next word. Given enough examples, the model learns which word is most likely to come next, then the next one after that, billions upon billions of times. At first, many researchers believed this could never produce genuine reasoning. It would simply become an incredibly sophisticated autocomplete. But as these models grew larger, something unexpected began to happen. Researchers found they weren't just memorizing text, they were developing internal computational strategies to solve increasingly complex problems. No engineer explicitly programmed these strategies. They emerged naturally during training. This is known as emergent behavior, when new capabilities appear simply because a system has become complex enough. Today, scientists are investigating whether these emerging capabilities function like simplified cognitive systems, not human cognition, but computational processes that perform similar roles. The first system resembles working memory. Everything the model knows during a conversation exists inside its context window. Within that context window, it tracks names, follows ideas across paragraphs, remembers earlier questions, and connects information from different parts of the conversation. Imagine waking up every morning with perfect concentration, but absolutely no memory of the previous day. That's surprisingly close to how today's language models operate. When the conversation ends, the context disappears. No lasting memory remains. It's a system with an extraordinarily detailed present, but almost no natural past. The second system is attention. For every word it generates, the model silently evaluates thousands of earlier words and asks a single question: which pieces of information matter right now? Some words become highly important, others are almost ignored. Without this mechanism, the model would lose track of conversations almost immediately. Unlike humans, who naturally read one word after another, modern language models can evaluate relationships across an entire passage at once. This is one reason they can summarize long documents, solve multi-step problems, and maintain surprisingly consistent conversations. Reasoning may be the most fascinating of all. Research shows advanced language models often perform better when they generate intermediate reasoning steps before producing a final answer. Instead of jumping directly to a conclusion, they build one step by step. Each new sentence becomes additional information that guides the next. In a sense, the model uses its own generated text as part of the reasoning process. Some advanced systems can even identify inconsistencies, revise earlier conclusions, or explore multiple possible solutions before selecting one. Researchers are still debating exactly what these internal processes represent. But whatever we call them, they produce behavior that increasingly resembles structured problem-solving. Perhaps the most exciting research today isn't focused on what AI says, it's focused on what's happening inside. Scientists working in a field called mechanistic interpretability are attempting to map the hidden circuits within these models. Some internal pathways appear specialized for recognizing names. Others help perform arithmetic. Others track locations, grammar, or abstract concepts. It's as if different parts of the network quietly divide the work among themselves, and nobody assigned these roles. They emerged naturally as the model learned. Understanding these hidden systems could help researchers build safer, more reliable AI, and may even reveal new insights into how intelligence itself is organized. Does any of this mean AI is conscious? Almost certainly not. Today's language models don't possess emotions, desires, or a continuous sense of self. Every conversation is a fresh beginning. But that doesn't make these discoveries any less remarkable. We're finding that processes resembling memory, attention, and reasoning can emerge, not from biology, but from mathematics and learning at an enormous scale. Perhaps the biggest surprise isn't that AI can imitate intelligence. It's that intelligence itself may be less mysterious than we once believed. Maybe some parts of cognition don't require neurons. Maybe they require only the right patterns of information. Whether that ever leads to something resembling a true mind remains one of the biggest scientific questions of our time, and we're only beginning to look inside the black box. Subscribe for more deep dives into how AI systems really work.